Hopefully you did a trial on the second problem on your own. You may have gotten stuck a little bit there at the beginning because neither one of these equations is solved for x to begin with. But that's okay because we know how to solve for a variable. So you can just pick one of these equations and solve it for the x or the y. It really doesn't matter which variable you solve for. And then you substitute what the variable equals into the other equation, into the remaining equation. So I took the second equation and solved it for x just because I could see that it would take the fewest steps. So when I did that, I went down here and that became my first step, was to solve one of the equations for one of the variables. So I solved for x, which means I had to subtract the y from both sides. Remember, you can't subtract or add letters from the numbers. So both of these terms remain on the right-hand side of the equal sign for the equation. So now x equals 2 minus 2y. Now I start with the steps that we went through on the first problem. So our step 2 is now to substitute this 2x minus y into our first equation. So that's using this equation right here, the negative x plus 3y equals 13. So I'm showing that substitution right here is that negative x is taken out and replaced with the 2 minus 2y. Remember, we always put parentheses around our substituted player. And we are going to have to distribute that negative or that negative 1 outside the parentheses into our parentheses. So I'm showing that here. So we get negative 2 plus a positive 2y plus 3y equals 13. That's my distribution of that negative sign from up here. And then we're going to join our like terms. So I'm going to put the two y's together. So I'm going to get 2y plus 3y gives me the 5y. Then I'm putting the letters on one side of the equal sign and numbers on the other. I start that by adding 2 to each side of my equal sign, which then gives me the 5y. It just drops down because I didn't do anything with my y's. And then I'm going to get 15 on the right-hand side of my equal sign. Then I have to undo the multiplication between the 5 and the y by dividing by 5 because I want y to stay there. So 5 divided by 5 gives me 1y. And then if I divide on the left-hand side, I have to also divide on the right-hand side by the same number. So 15 divided by 5 gives me 3. So if I did all my math right and simplified my equation correctly, then y should be 3 for this problem. So I'm going to take this y equals 3 and I'm going to pick one of the equations that was given to me originally and substitute that value of 3 in where the y is. So I went through and I picked the first equation to sub my value of 3 into. So I'm showing that substitution here. I actually did it for both. So you can see that we're going to get the same value for x no matter which equation we choose to substitute into. So showing that process right here as well as here for the second equation, depending on which one you chose to substitute the value of 3 into. Either way, we get x equals negative 4. So our next step is to write that answer as an ordered pair, which then becomes negative 4, 3, because the x value always comes first in an ordered pair and then the y value. Then the last step that we really have to do is to check our answer, our x and y values in both original equations. And I am showing that here. Here's the first equation. I got a true statement because 13 equals 13. And then also in my second equation, things just won't line up for me in this program. Sorry about that. So the steps are a little scattered. But I also get a true statement here. So as each check revealed a true statement, the point negative 4, 3 is the correct solution for the system. And since there is one point for the solution, then we call this an independent system.